Okay, simplify. This is your starter.
We'll simplify the 7 over 28.
Mm-hmm.
1 over 4.
Okay, go on.
2x over 1.
Yeah, and anything divided by 1 is itself, so that can be just 2x.
7, 1x squared.
Yeah.
So, yeah. And then, that'd be x over x.
So x squared is 2x's. On the bottom is 1x.
Yeah. Just x.
Yeah, x divided by x is 1. 1 times x, x. Okay. How do you add fractions?
Find the common denominator. So you could do 11 type. Well, this one you can do 11 times 9 is 99. So 99, and then 2 plus, and then another 1 to 99, and then you would do 7. Oh yeah, 7 plus, no, 9 times 7 is 9, 18, 63, and then 11 times 2 is 22.
So what do you multiply this other one by?
11 times 2.
Yeah, sorry. And that's 22. Okay. And so final answer?
85 over 99.
Yeah, and that's where all of algebraic fractions comes from. How do you multiply fractions?
Just do 7 times 11 is 77. 5 times 2 is 10.
Fine. How do you divide fractions?
Would you, forgot how to do this, would you find the common denominator, like the plus and minus, or what would you do for that?
No. For plus and minus, common denominator. For times, you just times across. For dividing, keep, change, flip. And so this is for dividing fractions. Keep the first fraction the same.
Oh yeah, you can swap it and then you times it.
Yes.
Yeah, I remember now.
How can you make this question easier at this point?
You could simplify them.
Yeah.
So the first one would be, can you simplify the first one?
So because you're multiplying these, you'll just bring them together. And you know how 3 times 2 is the same as 2 times 3?
Yeah.
So that means that you can just you can just swap them around. So I'll just swap around the top and just keep the bottom the same. And in the same way that I brought these two together, I can just as easily bring them apart. And so could you simplify those?
5 over 7 for the second one.
Yeah.
And then for the 7 over 16.
That's it. And if we go way back to this step here, instead of bringing the two together, swapping them around and pulling them back apart, you can cancel down. So if they're being multiplied, you can cancel down the fraction, or you can just skip that step and just check, is there anything I can cancel diagonally? And so you could say, well, I can cancel those two, 5 and 7, and I can cancel these two, 7 and 16. What is 7 over 7?
1.
And so what will your final answer be?
Just 1. Oh, 1 over.
1 times this other one.
Oh, 5. No, 5. Wait, am I? Yeah, 5 over 32.
What did that one simplify down to?
Oh, 5 over 16. Wait, what?
Yeah. So
Yeah.
14 over 32 became 7 over 16.
Right.
And I suppose this way we can diagonally cancel these 7s. And so we get 1 times 5 over 16 times 1, or whatever way you do it. It's just very helpful to cancel down. So you know how in order of operations, is it BODMAS you use?
Uh, BODMAS.
Yeah, so BODMAS, you have dividing and multiplying. Actually, they're like adding and subtracting. They're the opposites of each other. And so
Yeah.
it doesn't matter which one you do first and which one you do second. So we could have done 25 times 14, 32 times 35, and then divided. Or we can divide first, which makes the number smaller, and then times.
Right.
So with numbers, it's a bit tricky. It gets a bit easier with letters. Okay, let's do let's do B. What would you get for B?
6xy over 20.
And could you make that simpler?
No, because
6 over 20?
oh could you make that simpler? Because it's like xy at the top, so and 20 doesn't have xy.
Because
So that could be 3 over 10.
yeah, and you can do that because over is the same as divided by. 6xy is the same as 6 times x times y, and so it's everything is just either times or divide, so it doesn't break any BODMAS rules. And if we go back to the original question, we could cancel diagonally first. So 2 and 4, that could be 1 and 2. And and you end up with 3xy over 10. 3xy over 10. So try question C.
– 12 over.
Can you simplify first?
So that would. So what would you divide it by? Like.
Can you simplify 4 over 9 or 3 over 5?
4 over 9, that could work too.
So you can't?
No.
Can you?
No.
What about diagonally?
No. But yes, 1 over 3 that could be.
Well done. Okay, and so we divided first and now we can multiply.
So would that come together as one fraction, so 1 over 3?
Okay, so it's like 4 times 1 over 3y times 5y.
Alright, so it'd be 4 over 15y squared.
Well done. Any questions about that?
That's fine.
Okay, and so 6xy is short for 6 times x times y. So here they started cancelling for you. Let's just do it ourselves. Anything you can cancel here?
In the first one you can cancel nothing, but the second one you can cancel.
So let's forget all this. So this bit here.
Yeah.
Anything you can see that you can cancel. And it can also be diagonal.
So the 4 and 8, that could turn to 1 and 2.
Yeah.
and the y and 3, that could become 2, but can it?
No.
No. So,
What
1,
you
so,
can do... Sorry, go on.
would the answer be 3 over 2y? No, 2xy cubed.
You can make it even simpler. Would you be able to simplify y over y cubed?
Would that be... can you simplify that?
Yeah. So you can divide the top and bottom by y.
So 1 over...
Yeah.
So that'd be 1 over 3.
So y divided by y gives you 1. And
Mm-hmm.
so from the top and bottom, you can always get rid of like a y from the top and bottom. And
Yeah.
so it's 1 over... What's left on the bottom?
2.
2 y's, which is y squared.
No.
So that's like y to the 1. And so that can cancel. Okay, how about the x's?
X over... So that could be 1 over 1. Oh, so x over x.
X squared over x. That's the same as that. What will that simplify to?
Just x. Just x.
Just x, yeah. Okay, so that is just x. So let's clean this up a little bit. So that was 1x. That was times by 3. That's over y squared. And that's times by 2. Okay, so we've done all the dividing and now multiply.
Would you just do 1 times, so that'd be 3x over 2y squared.
Well done. And so this cancelling will just take a bit of practice, but it'll be worth it to make it easier.
Yeah.
Any questions there?
That's fine.
Okay. Okay. How would you do A?
Would you do x times x? So x 12 over x squared.
That would be if it was times. This is divide.
Oh, 4x over 3x.
So it's 4 over x. How do we divide fractions?
Switch the 3 and x about, so it'd be 3x, would it not be?
X over 3. So you keep, change, flip. Keep the first fraction, change to times, and flip the second fraction.
So that'd be 4x over... Would that not be 3x? Because that's 3 times x is 3x.
And can you simplify that?
No.
X divided by x?
Nothing.
Yeah, 1. And so what are you left with?
What would that make?
It would be 4 over 3 times 1 over 1.
So
Or 4 over 3 times 1.
3.
Yeah, 4 over 3 exactly. And what you, if you had noticed it in the very beginning, 4 over x times x over 3, those two x's are diagonal.
Yeah.
And so it'll work that way. Let's see. Okay, let's do B. Okay, we'll do B.
B.
Yeah. Nah, we'll skip B. Let's do C.
Divide, so 15. So would you do that diagonal cancelling out?
That works when you are multiplying.
Well, multiplying, right. So that'd be 30. Would that be x cubed, y cubed?
Yes. So are you doing keep change flip?
Yeah, 2 times 50, 2 times 15.
So, okay, so keep, change, and flip. So you're correct. But before you multiply those, let's now try doing the cancelling, because now it's multiplying.
That could be the 2 and the 8. The 2 could be 1 over 4.
Mm-hmm.
And the 15 could be divided by 5, so 3, and wait, 1 over 5, so 1, yeah, 3 could be the 1 and the 15 could be the 5.
Mm-hmm. Anything about the x's or the y's?
The y could, is that y over 7? That 4y to the power 7?
Right, what would change?
So that would become, that could become y to power 4.
Yeah, and yeah, go on.
Would that become y to the power? Would that just stay the same?
So it would be like y cubed over y to the 7. So the bottom became y to the 4. So you divided the top and bottom by y to the 3. Maybe I'll just hang on a sec. So if I don't skip the step, I'll just change the below. So 3y is on top.
Yeah.
1, 2, 3, 4, 5, 6, 7. And so you were correct when you said that it would be y to the 4. So that's y over y, which is 1, y over y. So you're left with y to the 4 on the bottom. What are you left with on the top?
Nothing.
So this y over y is the same as 1 over 1.
So just 1 over 1.
So what you're left with on the top is 1. It's 1 over y to the 4. So this y to the 3 becomes a 1.
Right.
And another way to think of it is you divided the top and bottom by y to the 3. And that's why you got 1. So you divided it by itself. Okay, how about the x's?
That become 1 over 2y.
X to the 2?
2x.
Yes, well done. X to the 2. Okay. Okay, so what's next?
That'd be 1. So you could do 1 times. What would that? 1? No.
So this, I think what we're left with over here now is 5 times 1.
So so that'd be 1 times 5 over, and then that'd be over.
And what we're left with here, it looks like it's 1x squared.
So
that's x squared times, what was this one?
4 to the power of 4.
So 4y to the power 4.
Yeah.
And what does this give you?
5 over. Would that just be x squared times 4y4?
Yeah, and the way we'd write it is put the number first and then the letters second. And I don't need to check if it can be simplified because we simplified it up here.
Right.
Okay. Yep. Any questions there?
No.
And then this next one. Let me just think about this. No, I'm going to leave Okay, how would you add these two?
Would you do 5 times 3? So that'd be 2 fractions over 15. Like under like the denominator 15, and then 5 times x. So on that second one it would be 5x, and the first one would be 3x.
Mm-hmm.
And then you do 3x plus 5x, 7x, so 7x over 15.
Not 7.
8, sorry.
Yeah, 8x over 15. Okay, so you're good there. What about this one?
4 times. So that'd be 12. So 2 fractions, 12x squared.
Okay.
And then 3 times 3. And then the second one would be 3x. First one would be 4x. So it would be 3x and 4x. So that would be 7x over 12x squared.
Can you make that simpler?
That could become just 7 over 12x.
Well done. Yeah. 1x on top, 2x's on bottom. And the reason why you were able to simplify that is because you see how you have x here and x here.
Yeah.
That means a common x was already common, and that means that actually you could have used the common denominator 12x and not 12x squared. But it's fine, you still got the right answer. It just meant you had to do a bit of simplifying at the end.
Yeah.
What you could have done was just multiply one by 3 and the other by 4, and you would still get a common denominator because x was already common. You'd still get 7 over 12x. Yeah, same answer. Yeah. Okay. Oops. Let's see. Okay, how would we do this one? X minus 4 over 2 is the same as what over 10? How would we do that?
So you would put the x minus 4 into bracket, would you? So that would be x plus 2x minus 2.
Nope. What do you have to do to the bottom so it goes from being 2 to 10?
Times by 5.
And so same thing up the top, and so times by 5.
So 5x plus 2x, 5x plus 2x minus 2.
No, there's no. You're thinking of difference of two squares. That there would have to be a squared somewhere. It's not difference of two squares.
That would just be 5x minus 4.
So 5 bracket x minus 4 over 10. Could you expand that bracket?
5x minus 20 over 10.
Yes. And so that is, I'll just write 5x minus 20 over 10. Okay, same thing. X plus 7 over 5 is equal to what over 10? How would you do that?
Plus 7 over 5. That would be, on the top, it would be 2x plus 14.
Yeah, okay, so you did that in one go. Using your two previous answers, do the question x minus 4 over 2 plus x plus 7 over 5. Or any way you like, how would you?
Would you do the whole 2 times 5 is 10?
Yeah, and
times 5x. So then have a bracket.
and if you if you check back, that's what you did do.
Yeah, so...
And you got 5x minus 20. Because you multiplied it by 5.
Yeah,
This one, same thing.
Yeah, 2x is 14. And then you would... So would you just 5x, so 5 minus 2x, that'd be 3x.
These are plus.
Yeah, but would you do the whole change side, change sign thing? So 5x minus 20 plus 2x plus 14. So would you move the 2x near the 5, which means you need to change the sign. So 2x.
That's if there's an equal sign between them. You're just adding two fractions.
Oh, how would you do that then? Because there's a...
So let me just... let's see. Let's make this. So if we go back to, let's say this one, they're both over 15, and so you can just bring them over one fraction. You can just, we skipped a step because it was so kind of obvious, but basically bring the two together over one fraction and then just simplify them.
Alright, okay, so you would just do
and so whichever way you like, 5x minus 20, what was it, 2x plus 40.
So you just do 7x minus 6 over 10.
Well done. And what we left out was a middle step that might make it more confusing. 5x minus 20 plus 2x plus 14 over 10. Yeah. Any questions about that?
That's fine.
And this all comes back to this thing where this one we had to times the top and bottom by 5. This one we had to times the top and bottom by 2. We just did them separately. Let me just go back a second. Okay, let's try B.
So B, it'd be 2 brackets, 14 with the denominator 14. Top would be 7x plus 35, and the second one would be 2x minus 6. And then the answer would be the denominator 14, and the answer would be 9x.
That would be if we were adding them. So I'm going to bring it over one thing. So it's 7x plus 35, take away 2x minus 6.
Yes, that would be 5x minus 29. That's 29, sorry.
Minus what, sorry?
5x plus 29.
How did you get 20?
29 because the 35 minus 6.
Okay. This is 35 minus 6.
Or positives, that'd be 41.
Well done. 5x plus 41 over 14. So this is a little trick, and this is why I did this intermediate step, which is to bring the two of them together. If you have minus both of these, so it's minus 2x and then minus 6. Another way to think of it is if you're subtracting a bracket, it's like it's minus 1 outside the bracket.
Yeah.
And if you were to expand that bracket, you would get minus 2x, and minus 1 times minus 6 is plus 6. And you could have had a second intermediate step. Hang on, before we move on, I want to try C, because what will catch you is the minuses. It might always catch you because it catches everyone, but let's just try C.
Two fractions would be over 36. One of them would be 9x plus 63, and the second one would be 8x minus 4. And then you would do over 36, so it would be over 36, and it would be 1x, so just x, plus 67.
Well done. Didn't catch it. Got it. Let's see. So this one is easier than the one we just did. That's an exam question. I'm happy you'll be fine there. Factorize. Okay, let's factorize each of these. What do we get?
First one we would get 3 bracket. No, we take out the x. Would you not?
They don't both have an x.
Yeah, so would you not take out the x, and then it would be 3 plus 6. 2 plus 6, sorry.
So take out a 3, 2x plus 6. Do 2x and 6 have anything in common?
3.
2
like,
and
2. They're both the bigger.
Yeah. And so if you take out 2 from those, then on the outside you would have like 3 by 2. And if you take out 2, what do you get?
1. It's just x. Plus 4.
You divide it out 2.
Oh, so it's 3.
3 times 2?
6.
And so if you had noticed it in the very beginning, they not only both have 2 in common, they not only both have 3 in common, they actually both have 6 in common. 6, 12, 18.
Yes. But how come? Yes, you would do. Yeah, right, okay.
Second one.
X bracket x plus 3.
Well done. Third one.
X squared bracket x plus 4x. No, just 4.
Yeah. And last one.
3x plus minus, not bracket, minus bracket x minus x, or not x minus 5.
Something's missing from this one. 3x times what gives you 3x to the 3?
X good.
Yes. Let's see. Simplify these. We're okay. Fully factorize, I think we'll be fine. Simplify. How would you simplify D?
So you would take out x, so you take out x minus 1, so that would just be x, so x plus 2 over x minus 5.
Yes. Okay. No. Okay. So you can fully factorize the top and bottom, and then you can simplify. We looked at that the last time. Fully factorize the top and bottom and simplify. Okay. Adding and subtracting. Okay. How would you do B?
B, x, with the bottom bit be x minus 1 bracket. So x minus 1 a bracket and a bracket x plus 5 and then over x. Wait.
Okay, so that's correct. You could multiply first and then simplify later. Can you simplify first, either straight down or diagonally?
Oh, you do. I'll be straight diagonally. So that would be x minus 1, x plus 5 at the bottom. Oh, yeah, wait, can you take the... Oh, yeah, and then it's just x plus 2 over x plus 5.
Plus 5. Okay. Okay. Okay, this is what I wanted to get to. How would we do this?
And the bottom it would be x plus 2 in a bracket, and then x plus 3 in a bracket, and then the top would it be 7x plus 21? This one, and then the second one it would be 3x plus 6. And then you would just do so would you put the x plus 2, x plus 3, x plus 2, x plus 3 together?
Yeah.
So that would just be x plus 3, which would make 4x plus would that be 50?
Well done. Any questions there?
No, that's all.
Okay, so this is adding and subtracting of algebraic fractions. That is not any more difficult. We did a minus one. That doesn't look any more difficult. Let's try this one down here. No, let's there is a little trick to it that can make it easier. Okay, let's do this one.
So 3x plus 9 in a bracket and 4x plus 12 in a bracket.
Yeah.
And then it would be over 4x plus 12 still. And then it would still be over thing. And so would they just calculate the...
So we'll do it properly. Okay, what would the first fraction, second fraction?
3x plus 9 or 4x plus 12.
And what's on the top of this one?
4x plus 12 still.
This one?
3x plus 9.
Okay, and bring the two together.
7x plus 21.
7x plus 21. Can you factorize the top?
1x plus 3.
And what is the common factor that you take out?
Or 1.
No.
Sorry, 7, 7.
7, yeah. Can you factorize the bracket on the bottom? Like 3x plus 9.
3x plus 3.
So that's 3x plus 3, and then that is 4x plus 12. Can you simplify your final answer? Sorry, can you simplify this?
7x plus...
No. That's less simple. Can you cancel anything?
Oh, the x plus 3 and the x plus 3, so that would just be 3, 4x plus 12, 7.
Yes.
7 over 3, 4x plus 12.
Yes. And so you could have either at the beginning factorized the bottom for both of them. I kind of like this way.
Yeah.
In general, fully factorize the top, fully factorize the bottom, and see if you can cancel anything down. So way back on this one, if this had been 4x plus 16, we could have factorized the top, and then we could have seen, does that cancel with anything? It just didn't factorize. That's kind of the same idea. I just want to see how tricky these get. Those are multiplying, and then those are mixed questions, really. Okay, so it looks like that's solving. These are the very hardest ones. Okay. We might just expose ourselves to one of these. How would you do A?
Would you just forget about that minus 4 just now? 8 equals 4 just now.
Right.
Or in fact, would that not be 4 over 1? Technically.
Okay, what about the left side?
So 5 over x equals, that just equals 4 over 1.
And then how would you get x equals?
So you would need to divide 4 by x, so that would be...
It's already divided by x.
X equals 20.
So to bring x to the other side, it's currently divided by x.
Times by it, so that'd be x equals 4x. No,
so that would cancel out the left bit, so you would get 5 is equal to 4x. And so what is x equal to, or how would you get that?
5 equals 4x divided by, so 20x. Would you not bring the 5 over and divide that by 5?
X times 4 equals 5. How do you get rid of times 4? So 4x is 5. How do you get 1x?
3.
Divide by 4.
Yeah, divide by 4 and then, so 5 divided by 4 is 20.
That's times 4. 5 over 4. Now I'm going too quick because I'm just trying to really. No, maybe I shouldn't go too quick. Okay, so we'd probably have to leave this one for another time. So this is actually solving equations. When you were doing algebraic fractions, were you solving equations or just simplifying fractions and stuff?
No, we're doing. I've got my notes here. We're doing simplifying algebraic just simplifying them.
Okay. So I was really, because I was just really trying to I shouldn't push it that much.
Adding
Okay, so I think you're good for that. Let's just check. So we did the hardest type, which is when you have not just x on the denominator, but something like ax plus b, 3x plus 9, 4x plus 12. The main thing is, multiplying everything and then fully factorizing the top and bottom in your final answer to see if you can cancel it down. Any questions in general about algebraic fractions, Harriet?
No, I think I'm good.
Okay, so you did up to the most difficult simplifying algebraic fractions, and that's good. I just wasn't sure if your thing had to be solving, but anyway, I pushed it too much. How was that for you, Harriet?
That was fine, yeah.
Anything in particular you want to do next time? Or
I
you
think,
can tell me, you can email or...
yeah, I'll text you maybe. I might go over still more. It depends what we're doing in maths, but I might just go over the thing that we're doing in maths at that moment.
Okay, so and you can tell me, or you can, if you're not sure, I can pick something.
Yeah.
Any questions for me in general?
No, I think that's fine.